Hello, my name is Andy Hawker and I'm with E&M Sales, and today I'm going to go over the basics of pneumatic valves and how they operate and how to correctly plumb them into a pneumatic circuit. Now, we talked about two types of valves. We talked about the inline valve, which again plumbs into the airline directly. We talked about the sub-base valve, where the valve is mounted to the sub-base and that's what's plumbed into the airline. The third type of valve that we're going to talk about is a manifold valve. A manifold valve is much like the sub-base valve, except that the sub-bases connect together, giving us common air galleries, so that the primary air or the line air from our air supply comes into one end or the other end plates and supplies the air to all the valves together. The valves can operate independently, having the cylinder ports located on the front side of these sub-base manifolds, and those then go out to the individual cylinders that we're controlling. The valves are very similar to the ones we talked about before. This happens to be a Pneumatics brand 2002 series valve. This valve has 5-port valves. This manifold has 5-port valves on it. These are a very small valve. The bottom two are dual solenoid, and the top two are single solenoid spring return valves. This also has on here an electronic interface so that this valve manifold is controlled through DeviceNet. So it allows field bus technology to control the valves. Pneumatics makes many sizes of their valve manifolds. This happens to be a 2012 series valve with single solenoid spring return, but it's really the same. Before, the other manifold we looked at had push-in fittings in the manifold subbase. Here we have NPT ports, but again, air comes in port number 1, just like we discussed before, and the exhaust ports are out here on the end plates, ports 3 and 5. 5-port valve, we have air coming out port 2 and 4 going to the cylinders. This manifold is a little different in that it does not have electronics capabilities, so there's no field bus connection. What it does have, though, is a sub-D connector, so individual wires can come into the sub-D connection to control individual valves. This also has an integrated muffler system in the end plates in this style of valve. One of the unique features that Pneumatics does in their manifolds, again, has to do with the electronics, the field bus control that they can do. But on two sides of the manifold, we have two distinct things that can happen. On one side, we can have the valves that we can control with field bus, various field bus protocols. And on the other side, though, we can have inputs and outputs that will allow us to have other components on our circuitry that we can control from this manifold going back to our controller. So we can control things such as limit switches, such as proximity sensors, lights, those types of things can have inputs or outputs on the manifold. This gives a great deal of capability, and Pneumatics is one of the leaders in the industry with what they're able to accomplish on their electronic packages.
Another one of the unique features of the Pneumatics brand of valves is the spool and sleeve design. The spool in the valve is matched to the sleeve with very close tolerances. The spool does not have any dynamic seals. Rather, the sleeve contains the seals, but they are static. Therefore, the spool is nearly frictionless in operation because of the air bearing effect created by the air pressure and the closed tolerances. You can see how the air bearing effect works in this example. Isn't that cool? It just keeps it going. Huh. The spool and sleeve are made from stainless steel and are very durable. This allows the valve to be self-cleaning and has been tested for over 1 billion cycles. This design was pioneered by Pneumatics and is the industry leader in the spool valve technology.